Hi everyone. So I have built an AI agent that can take a GitHub issue from a Go project and find the right files, generate a code change, run the tests, and produce a pull request. Let me show you how it works end to end on a real Cobra issue. So here I have the Cobra repository and the uh, assignment or the Go agent I have created. So the assignment asked for a framework, not a chatbot wrapper. So I built this six-stage pipeline. So it fetches the repository, index it, retry, then plan, then edit, then validate, and then summarize. And there is a retry loop between edit and validate. So whenever a standard error occur during the validation, it will again run the edit service, making an API or the LLM call again with a max retries of 3, which is dynamic and can be changed. So let's just follow the instruction inside the README. Uh, First, we have to clone the repository. I have already cloned it, so let me just go inside the repository and inside, let me just create the Python virtual environment. Since this is going to take some time, after which we have to just run this script and we just move inside the virtual environment. Since it's going to take some time, I will pause it. No, it's not work. So let's just move inside the virtual environment. Now we are inside the virtual environment. uh, Install the Python dependencies. Now it's going to take some time. I will pause it till we will continue after it. Now since it's just going to be completed, let me just walk you a bit around the folders. There are three folders that matters. Inside the agent, inside the stage, you have one Python module per pipeline stage. Inside the agent tools, you have reusable utilities, cell runners, rip grab wrapper, edit applier with sanity checks, and we also have prompt folder, the LLM prompt as plain markdown files, so we can edit them without touching Python. Now inside the agents, we have loop.py file. Here you can see this is the only place where stage order is defined that we have discussed previously, the sixth stage. And inside the edit.py of the stage, you, uh, the the LLMs actually emits the JSON operations, and this edit.py applied that to the corresponding file. Now since the uh, uh, dependency got installed, what we can do, we can follow the next step I describe here. We can copy the environment example file and create the environment. Now the environment file is good created. We are using here the Anthropic API key and the Claude Sonnet 546. So here I will use the traffic API key and here the default model. Since we can actually change the model in the attribute as a command passing, but we are making the default as this as we are using the Anthropic API key. Now, after the key is dropped in the environment file, the agent is actually fail fast. If Go isn't installed, if the key is missing or any issue come, it just appear when you run the command. So I will start with a dry run and let's just choose an issue in the Cobra. So let me just choose this issue. This the second one, 2376. So what we can do is we will first do some sanity check that Go agent is actually running. Go agent and yes, Go agent is actually running and it supports this four repositories. We can extend it to further two. Now here is the command Go agent Cobra is the repository name and the issue number. And we have two options. We are first going with the dry run. So what it will do, it will first what it will do, it will start uh, if so it will start with fetching the GitHub issue, fetching the issue, and then clone the Cobra repository inside the workspace, which is, as you see, is cloned, and then index every Go file into a package plus symbol map, and then rip grabbing the issue text against the code base to score the candidate files. Then one Claude call to produce a structured plan. So inside this plain.json inside the run, you can see that there is an hypothesis. These files need to be edited. We have find that this line need to be edited, and this files this have read to know that this files need to be edited, and there is an approach and there is an response. Now now the we only run the dry run, and the dry run only go up to the uh, plan stage. It doesn't make any edits or any validation step. This is just that user will able to know that what are the plans, as we can able to see the hypothesis, risk, and the approach. Now we will go to the full end-to-end run. Now full pipeline. Uh, uh, Plan plus edit plus validate plus summarize. So I will run Go agent solve Cobra 236, not dry run. So here you can see it fetches if and then index and then follow the all the steps, planning the change. Let me pause a bit since it's going to take some time as LLM response. Now since all stages got completed, we let me walk through the runs and its runs folder. The runs folder actually have a database of actually what happened in every stages and all the data that composed here. So this is an agent diary trace.json. You can see it's one line per LLM call and per tool call. Token counts, cost, prompt, preview, errors. Every reviewer can verify exactly what happened. Then you have changes.patch, uh, the actual unified diff. Apply it with git apply and you have a working branch. Then you have a pr.md file. It has a pr title and body, and it's honest about validation status. If test fail, the body says so, and everything. Now it's created by the name, the date and time, and the name of the repository and the issue. So every time you run the command, it's got created based on which repository you are running and which issue you are trying to solve. Now, since we have run this command, changes were already made inside the workspace of the Cobra repository. You can see it here that the changes were actually made onto bash completion.go and bash completion v2.go. And you can say see inside the plan too that files to edit will be this. So actually the whole pipeline actually ran, and there were and they only making one attempt, and this actually the validation actually run completely successfully. So the changes were applied. We we also have an evaluation feature as we go through the you know uh, instruction in the readme file. We also have an evaluation feature which actually allows you to check or compare your changes with the closed issues. So this command actually show you the that changes made by the Go agent and the changes made by the actual user and make an PR the difference. And here is the YML file picture.yml which actually contain it. Uh, hmm. The fixer.yml file, you have to just put the repo name, the issue, and the PR that is actually want to compare with, and in the description you want, and just run this command that is given in the instruction. Go away, and it will make an LLM call in context with your changes and the changes that are applied, and create an score of how your changes and um, the actual changes differ, or what are the pros and cons. This project has future scope of improvement. While the current system works well, there is definitely room to make smarter. First, we can use a better retrieval method where instead of feeding the entire file, we can uh, feed with more accurate and data to the LLM about the file changes that we need to make and the exact code part. And the other way I can think of is making a better pipeline which can solve an issue directly based on the issue created on the GitHub. We will replicate the issue on our side using the Playwright MCP server. So it will first try to replicate the issue on the local machine, on the browser or the terminal, uh, or the other way, and then it will trace the actually code flow that's happened during the whole process of reproducing the issue, and find the gap in between and make a solution based on that. So together there are those two other method I can see we can improve it exponentially. So that's from my side, and thank you so much for watching.